Hello guys, welcome on Tesla Adventures. Now, after that previous video on the projectile motion basics, in this video we'll be deriving the expression of maximum height, range and time of flight. We'll derive these relations by two different methods. So let us discuss the first method. So first of all, we know that the maximum height of the projectile is the greatest height attained by that projectile in its complete motion from the ground. This is h max. And the range of the projectile is the greatest displacement of the projectile along the ground in the complete motion. And the time of flight is the time in which it again comes to the ground. Okay. So now, let us first of all focus on the time of flight, and let us first of all discuss that y is equal to uy into t minus half g t square. What I have done, I have applied the equation of motion, second equation of motion along the y-axis, y direction. This is ux and this is uy. Ux is equal to u cos theta, while uy is equal to u sin theta. Okay, so y would be, now we are talking about this complete motion. So in complete motion, the y coordinate would be 0 because the displacement in y direction is 0, because ball started from ground and landed on ground again. So in complete motion, y is 0, and 0 is equal to uy into t minus half g t square. Okay, so obviously if we are substituting the value of y to be 0, then this time would be the time of flight. Okay, because y would become 0 after the time of flight. So you can see that there are two solutions of this equation. The first solution is t is equal to 0, and the other one is t is equal to 2uy by g. So obviously the particle is on ground at two instant of times. First is initially, and the second instant is finally, when it has completed the motion. So we can say that time of flight would be the second time, which is 2uy by g, and uy here is u sin theta. So we can write that time of flight is 2u sin theta by g. So this is the time of flight formula which we have already obtained. Now we know to obtain the maximum height, let us first of all use the y direction. So in y direction, we know that at the top point, at this point, vy is 0, but vx is equal to ux, which, because we have already discussed this fact that in the projectile motion, at all instants of time, the x component of velocity will remain constant. So at the top point also, the x component of velocity would be ux, which is u cos theta. So in the y direction, if we apply v square is equal to u square plus 2as, then we can say that at the top point, vy will be 0. Okay, and uy is u in the y direction is uy, and you can see that the displacement in the y direction is in the upward direction, h max, while the acceleration due to gravity is in the downward direction, g. So there would be a negative sign due to the fact that h max is in upward direction and displacement due to gravity, in fact acceleration due to gravity, is in the downward direction. So h max is equal to uy whole square upon 2g, and you can substitute the value of uy as u sin theta. So this is u sin theta, u square sin square theta divided by 2g. This is the equation of height, maximum height attained. Now let's move on the third one, which is the range. Now to find out the range, let us analyze the x motion, because obviously we know that range is the maximum displacement of the projectile in x direction. So we know that in x direction, in x axis, the velocity ux is constant. So ux is equal to u cos theta. So we can say that the range would be the displacement of the projectile in the complete time of flight along x-axis. You can see that the time of flight is the time taken by the projectile to move from this point to this point, and therefore the displacement of this point and this point measured along the x-axis is r. So we can say that r is the displacement along x-axis traveled in complete time of flight, and therefore r can be written as ux into time. So r will be u cos theta into 2u sin theta by g. So r will be equal to u square sin 2 theta by g. This is the range. Or you can also write down the range in another form, that r is equal to, this is ux and this is uy, so r is equal to 2ux into uy by g. Okay, so this is the range. Now let us move on the different method of these derivations. So let us discuss that method. So we know that the equation of trajectory y was x tan theta into 1 minus x upon r. So we know that in complete motion the displacement along y-axis is 0. So let us substitute the y as 0 and therefore x tan theta into 1 minus x upon r is equal to 0. So you can see that x is equal to 0, and from equating this, then we can say that x is equal to r. Okay, and this is the range. But we know that we have to find out the value of range also. So we will use the equation y is equal to x tan theta minus half g x square upon u square cos square theta. So in complete motion y is 0. So y is 0, then x tan theta is equal to half g x square upon u square cos square theta, and cancelling out this x with x. So x will be equal to 2u square tan theta into cos square theta is sin theta cos theta divided by g. So we know that this x is equal to r, obviously we have already derived. So r is equal to 2 u square sin theta cos theta divided by g, which we can also write as this one and this one. So this is the formula of range by equation of trajectory. And now let us find out the maximum height by equation of trajectory. So to find out the maximum height, we know that y is equal to x tan theta minus half g x square upon u square cos square theta. So you can see that in this motion at the top point the slope is 0. Obviously if we find out the slope of this parabola at top point, then it is 0. So dy by dx is the slope, and dy by dx is tan theta minus gx upon u square cos square theta. And if we equate this slope to 0, then x is equal to tan theta, and this, if we equate it to 0, then x is equal to tan theta into u square cos square theta by g. Okay, so this is x, and you can see that this x is obviously r by 2. So this is r by 2. And if we substitute the value of x in this equation, then y is equal to, or we can substitute the value of x in the another form of trajectory, which is x tan theta into 1 minus x by r. So if we substitute x as r by 2, then this is r by 2 tan theta into this is 1 minus 1 by 2. So this is r by 4 tan theta. Now we know the formula of r, and let us now substitute the value of r. So r is equal to u square sine theta cos theta by g into 2. So we know that y max, this is y max, is r by 4 tan theta. So this is y max is the maximum height, h max, which is r by 4 tan theta. So u square 2u square by 4g and tan theta sine theta cos theta. Now we can cancel out, we can solve this equation. We would be getting u square by 2g into sine square theta. This is h max, which we have already discussed. So the maximum height is equal to uy whole square upon 2g. Okay, so this is the two method derivation of maximum height and range. Obviously we cannot find out the time of flight by using only the trajectory equation, because in the trajectory equation there is no term of time. So obviously we cannot find out the time of flight, and time of flight we have already derived. Okay, now in the next videos I would be bringing some very important concepts of the projectile motion, and those concepts would be very useful in solving the complex problems of projectile motion. Thank you.